All right, let's look at the product rule for log functions, and that says if you've got a log with some base of x times y, that's equivalent to log of that base x plus log of that base y. And I want to show you why or how that would be true, just to give you an example, a concrete example. So here's my kind of general rule of thumb that helps me keep straight the relationship between exponential functions and logarithmic functions. 10 squared is equal to 100, so log base 10 of 100 is equal to 2. So log is sort of answering the question, what do I have to raise the base, um, to what power do I have to raise the base in order to get that number? So the base is 10, I have to raise it to the power of 2 to get 100. Okay, so so let's look at this one example. Log of 1,000 or 10,000, and I'm just gonna say log. If it's implied that it's log base 10, unless I specify a different base. Okay, so that's log base 10 of 10,000 is equal to 4, right? Because um, 10 because 10 to the fourth is 10,000. Right? I have to raise that base 10 to the power of 4 to get 10,000. You know, it's 4 zeros behind there, right? Well, I could look at this 10,000 as 100 times 100. So this is equivalent to saying log base 10 of 100 times 100. Right? 100 times 100 is 10,000. Okay. Um, well, the product rule tells me that if I've got a log of the product of two things, I can split those things up like this. So I could say log of 100, that's equivalent to saying the log base 10 of 100 plus log base 10 of 100. So log of 100 is 2. You know, 10 to the power of 2 is 100. Log of 102 equals 4. Right? Okay. See that connection? So this is just a concrete example to kind of show you where this is coming from. So it has to do with, you know, if I take 10 squared times 10 squared, that equals 10 to the 2 plus 2. Okay, this is where this is coming from. All right, so let's try let's apply this product rule on a couple of examples. So log, again, I don't specify the base here, so it's assumed that it's base 10. So log of 100x is equivalent to, by this product rule, log base 10 of 100 plus log base 10 of x. So log base 10 of 100 is 2. So I could do that one. Say that's 2. 2 plus log of x, you know, is equivalent to this. So maybe in the process of solving a logarithmic equation or something, if I see something like this, it might be easier to solve it if I rewrite it as, you know, for example, 2 plus log of x, for example. That's kind of the value of the product rule. Or vice versa, I might have something that's split up and it'd be easier to take the log of the product of those two. So, okay, so here we have log base 4 of 32. You know, you can do that on your calculator, or you could apply the product rule and make the calculation easier. So, what is 32? 32 is equivalent to, for example, 16 times 2. So I could rewrite that as 16 times 2. Right? So this expression would be equivalent to log base 4 of 16 plus log base 4 of 2. Now, keeping in mind what is a logarithmic function? What does this mean? So 10 squared is 100. That means log base 10 of 100 is 2. So this is asking the question, what power do I have to raise 4 to in order to make it into a 16? Well, the answer to that is 2. 4 squared is 16. So log base 4 of 16 is 2. Okay. Again, log. So what power do I have to raise 4 to in order to make it into a 2? I have to raise it to the power of 1/2. In other words, I have to take the square root of it. Square root of 4 is 2. So by applying this product rule and then applying what I know about logarithms, I can simplify this into, it's just 2.5. Boom. I don't need a calculator. So yeah, take that, calculator. All right, so that's a product rule. It's very useful. You'll need it to go both ways, and you'll need it to simplify um, logarithmic equations just to make them more solvable. So keep an eye out for when you can convert, one way or the other here with the product rule.